Hello everyone. What I'm going to go over today is how to go through most of Lab 10. It is suggested that you watch the other videos so that you can see how the equipment works, but I'm going to go over a few of the details and tell you what you need to turn in. So what I'm going to need you to turn in this time is this page right here, which is page 49, and this page right here, which is page 50. The lab talks about in the instructions doing a graph. I am not going to require you to do the graph. Because of that, since I'm not having you do the graph, I'm going to be talking you through the answers for questions 2, 3, and 5, which have to do with the graph. I'm going to give you a different way to do question number 4 than what is actually mentioned in 4. But first, let's take a look at what we've been given. So hopefully you've watched the other video, you've seen the air track and the cart and the hanger that's attached to the cart by the string. And the whole idea is that we're going to have masses on the cart and masses on the hanger. And if you add the masses on the cart, the masses on the hanger, and the mass of the cart and the hanger themselves, it comes out to be this amount of kilograms. So this is the cart, hanger, and all the masses that are on the cart and or the hanger. We're going to have 5 different hanging masses, and how we get this is we start out by having the hanger with just one mass on it. And we get that mass from the cart. And every time we want to change the hanging mass, we'll just take one of the weights on the cart and move it onto the hanger that's attached to the string. That way the system remains the same. We're not changing the mass of the system that we calculated here. Instead, it's going to remain the same throughout. We're just moving the masses around from the cart over to the hanger. We're going to have the hanging mass, and from that you're going to calculate the accelerating force. I'll tell you how to do that in a moment. And when we run the experiment, we measure out a distance. In this case, we measured out a distance of 1/2 meter. And we set up a couple of sensors separated by the 1/2 meter that are attached to a timer, which then tells us how long it takes for the cart to move that 1/2 meter. For trial 1 is these 3 times right here: 1.7118, 1.7653, and 1.699. So what you'll do with these 3 times is take an average of them. So add the 3 and then add all these and then divide by 3. And that goes right here. And then there's something you will need to do. Let me grab this. There's something you'll need to do. I want you to add another column, and I'm going to draw this column right here. Hopefully you can draw it better than I can. I'm using this tool that's on Zoom, and well, it's not easy. It's not exactly an easy way to draw a straight line, and I have trouble drawing straight lines anyway. And this column is going to be the t squared column. And what you'll do is whatever average time you get here, you're going to square this time and put it right here. That will fill out, so you'll have this column filled out, you'll have this column filled out, and you'll have this column filled out And then you'll be able to do this column. And what this column is if you notice, it gives you the formula for it. 2d over t squared. That's why I've asked you to make this column right here, so that you have a place to write the t squares and keep up with the numbers. 2d is 2 times the distance. So here are your distances. You're going to need to multiply each of them by 2. Well, they're all 0.5. And 2 times 0.5 is 1. That means for this column right here, you're going to take 1 and divide it by your t squares. I'll give you an example of how to do that in just a moment. Then down here, for question number 1, please ignore this. This is going to move with me, unfortunately. For question number 1, it wants us to rearrange this formula. So if I do that, it wants me to rearrange this to solve for mass. So I need to divide both sides by A. When I do that, I get m is equal to force divided by acceleration. So here I want you to write 1, 2, 3, 4, 5, and average. And what these numbers are going to be, and again I'll show you this in just a moment, is you're going to take this number right here, the force, and divide it by the acceleration that you calculated over here. So let me do one of these for you. I'm going to erase this stuff for now. This should hopefully give you an idea of how this works. One moment, I'll get this. There we go. All right, so again, this first number is going to be using the hanging mass, and we're going to multiply the hanging mass by 9.8, which is the acceleration of gravity, and that will give us the accelerating force. So on this first one, it's going to be 0.007 times 9.8. And what I get is I really get a good point there. So try it this way. So what goes there is 0.06. Like this, 0.0686, which is just this multiplied by 9.8. There we go. For this, I'm going to take these 3 times and get the average. So 1.7118 plus 1.7653 plus 1.699. Go ahead and put enter, then divide that by 3, and here I get 1.725. Now I'm going to square that and put that right here. So if I square this, I get, grab this, 2.977. Okay, so we've got the average time, which is just these three numbers averaged together. Take this and square it and put that in this column over here. And then we need to find the acceleration. And the acceleration is going to be 2d, which is 0.5 times 2, which is 1. 1 divided by this number right here. And for that, I get 336. So that's how you get these numbers. Get this one, multiply this by 9.8. That times 9.8 will give you this. You get this number, average these three numbers right here. To get this number, take this number and square it. And then you're going to take 1 divided by this to give you here. The 1 comes from multiplying 0.5 by 2. Now, once you have these numbers, you're going to come down here. And you're going to, as I had this earlier, m is equal to f over a. So here's f, and here's a. I'm going to divide those two numbers now. So 0.0686 divided by 0.336. And what that gives me is, let me now erase these so I can get them out of the way. So what that gives me is for trial number 1. For trial number 1, I've got 0.204. And what we're doing here is we're calculating the mass of the entire system. So with this first number, this 0.204, that is approximating this number right here, 0.2162. So once you're going to do this for all 5 rows. You're going to come down here and calculate the mass for each row, just like I did here. So just do every step I did, just with the numbers for each row. You're going to end up with 5 masses, which you're going to average together, and their average should come out to be this. In other words, we should be able to calculate the mass of the cart and all the little masses and the hanger. We should be able to calculate their mass with just the mass that's on the hanger and the what is going to basically be the acceleration that this mass causes the cart to have as it starts to move. So that's how to fill out this table and how to do question 1. On question 2, when you calculated the slope, which you're not going to do, what were the 2 units of measure that you divided? You divided force and acceleration. Number 3, what then did you find by calculating the slope You found the mass of the system. Number 4 asks you to use the slope and plug it into the experimental error formula. So what you'll be doing is you will take your calculated mass, the average mass. You're going to take the average mass that you calculated back here in problem number 1. So you get the masses for each row, you're going to then average those, and you're going to take that average mass minus, get this up here so it's a little bit easier to see, minus what the mass should be, which is 0. Sorry, that's a 0. 2162. So this number right here, you're going to divide that by 0.2162, and then multiply that by 100, make it into a percentage. And don't worry if you can't read that. I will now scroll this back down. So this is your formula for question number 4. The average mass that you get for question 1 minus 2.162. Go ahead and hit enter, and then divide that by 0.2162, and then multiply that by 100 to get your final answer. And again, I probably hit enter before I multiplied by 100. Number 5. Why would you draw a line, a best fit line, through 0, 0 for this type of problem? Well, what is the 0, 0 representing here? Basically representing how much acceleration you're getting with a certain amount of a hanging force. So if you have no force on the hanger, basically you don't have a hanger there at all, and it's just the cart sitting on the air ramp with nothing attached to it. What is the cart's acceleration going to be? The cart's acceleration is going to be nothing. It's just going to sit there because there's nothing pulling on it. So if I have no force, I'm not going to have an acceleration. Number 6, how did you keep the mass of the system constant? I'll answer this one for you. We kept the mass of the system constant by moving the mass from the cart to the hanger. We kept each mass, we moved them around, but we kept each mass in the experiment. We would just move them from one place in the experiment to the other. We'd move them from the cart over to the hanger. Or vice versa, we could move the mass from the hanger and keep it constant by moving that mass from the hanger to the cart. But that's how we keep the mass constant. If we move a mass from the cart, we put it on the hanger, and vice versa. Using what I just mentioned for question number 6, see if you can come up with an answer for number 7. How would you perform this experiment if you wanted to keep the force constant but vary the mass? And then on number 8, give some source of error in this experiment. So I'm leaving questions 7 and 8 for you to do on your own. And hopefully that will get you through this lab. Again, you're only turning in these 2 lab pages. I'm going to mention that these are due, and I'll go back here. So these are going to be due because they're in the week 8 and week 9 folder. They're going to be due on October the 25th. Turn in those 2 pages on Blackboard by October the 25th. I will accept I will accept late labs from this set of labs, but I'm going to count off a point for every 2-week period they're late. And then starting week 10 and week 11, you must have them in by you must have the labs in by whatever the last date is for the folder that they're in. So, for instance, week 10 and 11 has lab 13 and lab 5 in them. So you need to have that done. You'll need to have those done by November the 8th. And, I'll set for this folder to close on November the 8th. So if you don't have them in, you won't be able to turn them in after that date. All right. I will see you next time.